Let's look at the example of the charged plastic rod being brought near tiny pieces of aluminum foil confetti. This is an interesting example because it combines so much of what we've learned during this unit on static electricity. The plastic pipe has been rubbed with a piece of rabbit's fur, which causes it to gain a negative charge. Let's begin by drawing the charge diagram for the plastic pipe. Start by drawing the positively charged particles for each charge pair. The exact quantity isn't important as long as we draw them throughout the object. The plastic pipe is negatively charged. We need to add extra units of electrons. Let's take a look at the foil particle. If it is near the negatively charged rod, and since it is neutral, it will become polarized. So let's show that first by drawing the positively charged particles inside it. It is neutral, so it will have the same number of units of electrons, except these electrons have been shifted. The negatively charged plastic rod repels these electrons and pushes them in this direction, pushes them down. Because this material is a conductor, we don't draw the ovals. So we signify that these electrons are mobile and they easily shift downwards. So because of this, because of the polarization of this piece of foil, the top part of the foil is positively charged, and the bottom part is negatively charged. As a result, the positive charges here are attracted to the negatively charged rod, and the piece of foil as a whole experiences a force upwards. It attracts up to the plastic rod. When the foil moves up and makes contact with the plastic rod, electrons are able to transfer from the rod to the piece of foil. Let's take a look at this. So extra electrons from the plastic rod are going to move to the foil. And let's say 2 units of the electrons move. The piece of foil now becomes a charged conductor. Because of this, we do not draw it polarized anymore. We show it first as a neutral object, and now with 2 extra units of electrons. So when an object becomes charged, we no longer show its polarization. Based on our observations from the experiment, we noticed that this piece of aluminum foil was pushed away very rapidly. And what that means is that these 2 objects are repelling each other. The foil is negatively charged, and the plastic pipe still has some extra units of electrons, so it remains negatively charged. And as a result, these 2 objects repel each other. Remember, when we draw charge diagrams for a charged conductor, the excess electrons are not attached to a particular charge pair. In an insulator, the extra electrons are attached. So here, we show those 2 units of electrons spread out from one another on the opposite sides.